Greetings everyone, welcome to today's video. I'm Clifford Mwenda, GMAT trainer of the KLF program. For today's video, we'll be doing a few DS questions and see how we can perform in these work questions. We've already done the concept, so just dive into the questions at the moment, do a little bit of a refresher and see what you can remember so that you can do the questions. So our first thing was doing amount of work, which was the rate times time. I hope you can all remember that. If you're not familiar with that, you can go to the link in the description box, click on it and watch the video. Then we talked about the types of questions in the work topic. We had those that involve only proportions and those that involve multiple machines and workers. And the strategies themselves were, for those involving proportions, you have to have uniform units. Yeah, we have also to use proportions to solve the question, just as simple as that. And for those involving multiple workers, we had to combine the rate by adding. That's how you have to find the rate using proportions, and that's the inverse of the time in most of the cases. So you create the rates, then add the rates together. Nothing else can be can interact with each other. It's only the rate. And with that in mind, now we can go through the structure of the DS question. This question is found in the data insight section, and they're very common, and it's good for you to be good in this question so that you can do good in your data insight section. So the structure itself has three parts, the DS question. And the first part is the question prompt, where we have the information and the question itself. We have two types of DS questions. We have the yes, no, and you also have the value questions. After that, we have the two statements. We have to evaluate each statement independently first, and then combine the statements if both of the statements independently are insufficient or not sufficient. Sufficiency is based on, does the statement give you enough information for you to answer the question confidently in the question prompt? Yeah, as simple as that. I'm sure and confident that most of you are familiar with these questions. If you're not, you can join the training. These are the answer choices, so I'll not be talking about the answer choices or not sharing the answer choices. I'll just be sharing the questions in the format where you have the prompt and the two statements. Okay, so if you're not familiar with that, screenshot the answer choices or have them by your side while we do the questions. If you are familiar, then we can jump into the questions. Right, so let's start easy and elevate. So we have this question, sub 500 question. Pause the video, give it a try, and then I'll jump in. Who types at a faster rate, John or Bob? Right, I like to rate my answer choices 12, 10, A, B, C, D, and E. So who types at a faster rate? Is it John or Bob? It's a value question. It's either John or Bob. So the first statement, the difference between the typing rates is 1 word per minute. Yeah, it might be John that has the higher rate or Bob that has the higher rate. So this does not give us enough information for us to confidently say it's John that types faster or it's Bob that types faster. So for that case, this is not sufficient. If one is not sufficient, then A is out and D is out. Right, let's go into statement 2. Bob types at a rate of 80 words per minute. Right, now we have the rate for Bob, but we don't know the rate for John. So for this case also, this statement does not give us enough information for us to confidently say John is faster or Bob is faster. In that case, if it's not sufficient, then B is out. Right, so let's combine the information from both of the statements since both of them are not sufficient. So, the difference between the typing rates is 1 word per minute, and Bob types at a rate of 80 words per minute. So does John type at 81 words per minute, which makes John, if Bob had 80 words per minute. Then does John have, sorry, yeah, that goes, so does he have 81 words per minute? Or does he have 79 words per minute? If John had 81 words per minute, then John will be the faster person. Then if John had 79 words per minute, then Bob would have been the faster. So we still don't have enough information for us to confidently say John is faster or Bob is faster. But guess, even when combined, statement 1 and 2, still not sufficient. In that case, C is out. And we have our answers E.
You are watching Success with Bob Mwiti Show, presented to you by the Kenya Airlift Program. The Kenya Airlift Program is an award-winning education financing scheme that helps bright Kenyan students to pursue graduate studies in North America, regardless of their financial background. You can find our programs by going to www.kenyaairliftprogram.com. The Kenya Airlift Program, empowering dreams.
Let's go on to the next one. It's another sub 500 question. Let's pause the video, give it a try, and then I'll jump in. Okay, so machine X runs at a constant rate and produces a lot consisting of 100 cans in 2 hours. So X produces 100 cans in 2 hours. That makes it 50 cans per hour. Let's make it a unit time. Then you have how much less time will it take to produce the lot of cans? That's the 100 cans if both machine X and Y were run simultaneously. Now, what happens, or how many cans can be produced, or how much time will it take X and Y to produce 100 cans? Yeah, so statement 1, both machines X and Y produce the same number of cans per hour. That makes, if X produces 50 cans per hour, then Y also produces 50 cans per hour. Then we can figure out how long does it take X and Y together to produce these 100 cans. After finding that, then you can determine how much less time will it take. So in that case, this is sufficient. We don't have to do the question. That's the beauty of the DS questions. If it's sufficient, then you don't have to combine the statements. So C and E are out. So what we're left with is A, B, and D. And also B is out because B states that 1 is not sufficient. So for 2, it takes machine X twice as long to produce the lot of cans as it takes machines X and Y running simultaneously to produce the lot. That means then, if X takes twice as long, then half the time that's the time at which machine X and Y running simultaneously produces the same lot, and therefore doesn't have to do any calculation. Already know this is sufficient. A is out. Okay, and our answer should be D. Right, let's go on. A level higher, we have 555 to 605. Working together, Rafael and Salvador can tabulate a certain set of data in 2 hours. In how many hours can Rafael tabulate the data working alone? So this is a valid question. So we need a unique value so that we can determine sufficiency. So what we know from the prompt is 1 over R plus 1 over S equals to a half. Okay, let's go into the statements. 1, working alone, Rafael can tabulate the data in 3 hours less time than Salvador. So Salvador minus 3 equals to the time for Rafael working alone. So what you know is that we can use this, or say make Salvador the subject formula and have R plus 3. So I'm going to replace the S in this with R plus 3 and solve for it and get the number of hours Raphael can tabulate the data working alone. So statement 1 is sufficient. If it's sufficient, you don't have to combine the statements, and also B is out. Statement 2, working alone, Raphael can tabulate the data in half the time that Salvador working alone can tabulate the data. So Raphael equals to Salvador divided by 2. Okay, so with this, you can also replace the values, Salvador being 2R in this, and solve for it. And therefore, we can find a unique value. Therefore, also, statement 2 is sufficient. And this means A is not the answer, and the answer will be D. Okay, so let's elevate a little bit and have discussion. Pause the video, give it a try, and see how it performs. So a tank containing water started to leak. Did the tank contain more than 30 gallons of water when it started to leak? And we have a note, 1 gallon equals to 128 ounces. Statement 1, did the tank contain more than 30 gallons of water when it started to leak? Yes, no question, we have to be confident about it and see how these statements portray themselves. So we have the water leaked for statement 1 from the tank at a constant rate of 6.4 ounces per minute. So how long did it leak for us to determine if the tank or the tank contained more than 30 gallons of water? Yeah, so if it were, for instance, a lot of times or lots of hours, then we expect that the tank contained more than 30 gallons of water. But if it was minutes that the water leaked from the tank, then we can determine that the tank didn't have more than 30 gallons of water. So for this case, we need the number of hours or minutes or time, the time specified, so that you can determine if the tank contained more than 30 gallons of water or less than 30 gallons of water. So for this case, statement 1 is not sufficient. So if it's not sufficient, then A is out and D is out. Let's go to the second statement. The tank became empty less than 12 hours after it started to leak. Now, we have not carried the information from statement 1, but we can see we need now the rate. This is also not sufficient, and therefore B is out. Let's determine if we combine these two statements, so we can have enough information for us to confidently say the tank contained more than 30 gallons of water or less than 30 gallons of water. So let's determine that. We have the water leaked at a constant rate of 6.4 ounces per minute, and the tank became empty in less than 12 hours. So let's say at 12 hours, we have 6.4 gallons for every minute in these 12 hours. So 60 divided by the number of ounces, 128. So you can have a 64 times 12 times 60 all over 1280 because of the decimal place. So cancel out a factor of 10, 64, 1, 64, 2. By 2, 1, by 2, 3. So this gives us 36 gallons. So the tank contained less than 36 gallons, but 35 gallons is more than the 30 gallons. So can you confidently say the tank contained more than 30 gallons of water or less than 30 gallons of water? For 35, yes, it's more than 30 gallons. If it were 20 gallons, then it is less than 30 gallons. So we have a yes, it contained more than 30 gallons of water, and then no, not contain more than 30 gallons of water. So then not say confidently, yes, this tank contained more than 30 gallons of water or less than 30 gallons of water. So for that case, C is out. Still not sufficient. We have E as our answer. Okay, here's our last question of the day. Let's give it a try. Okay, so we have machines K, M, and N, each working alone at its constant rate, produce one widget in X, Y, and 2 minutes respectively. So K produced in X minutes. We have M produces in Y minutes. And we have N that produces in 2 minutes. So if machines K, M, and N work simultaneously at the respective constant rates, does it take them less than 1 hour to produce a total of 50 widgets? Is it yes or no confident? Okay, so let's go straight to the statements. We have statement 1, X is less than 1.5. Right, so K produces a widget in less than 1.5 minutes. This means that K produces more than one widget in 1.5 minutes. So in 60 minutes or in 1 hour, divided by 1.5, we'll have 600 divided by 15, which is by 3, gives us 5 by 3. This gives us 200, and this gives us 40. So in 1 hour, K will have produced more than 40 widgets. What about now? Z, not Z, but N. What about N? So for that case, N produces a widget in 2 minutes. What about 60 minutes? So 60 divided by 2 gives us 30 widgets. So working together, even when not looking at M, K and N can produce more than 70 widgets per hour. That's 40 plus 30, 70 widgets per hour. So this is sufficient. Since it's sufficient, then we don't have to combine the statements. C and E are out, and B is also out. So B, C, and E. Let's go into the second statement. Now, we know that M produces a widget in less than 1.2 minutes. Therefore, in 1.2 minutes, M will produce more than one widget. Therefore, in 60 minutes, the same as K, we have 60, the 600 divided by 12, by 4, 3, by 4, this is 15, and 50. This gives us 50 widgets. So without even including machine N, we've already produced 50 widgets, more than 50 widgets, just looking at machine M. If we include machine N, then we also have another 30 widgets. This gives us 80 widgets in 1 hour, more than 80 widgets in 1 hour. Therefore, this is also sufficient. A is not our answer, and D is our answer. Yeah, that is the end of today's video.